Can you hear me? Hello, can you hear me?
Yes.
Okay, can. Right. We continue with the sum of first n terms. Now, if you look at this sequence, this is an arithmetic sequence, 2, 4, 6, 8, 10, and so on. So let's say I want to find the sum of first four terms, 2, 4, 6, 8. I want to find the sum of first 2, 4, 6, 8. First of all, I want to know how much is the A. How much is the A? Do you know how much is the A?
2.
2, correct. How much is the D?
2.
2, correct. So what we want to find is sum of first four terms. Sum of first four terms, right? So what I want to find is S4. So the formula tell me here, the formula is here, or you can use from here, right? Move the formula nearer so that you can see. This is the formula. Sn equals to n over 2, 2a plus n minus 1t. Right? Okay, so n over 2. So I put down n over 2. How much is the n? Can you tell me how much is the n?
8.
I want to find the sum of first four terms. What's the n?
4. 4.
4, then divide by 2. This number is always 2. You cannot change, right? So n over 2, now we have 2a. 2 times a, you told me just now, is 2, plus n minus 1. So it's 4 minus 1, and you told me the d is 2. So this will be the sum. I try to work out and see whether this is the sum of the first four terms or not. 4 divided by 2 is 2. 2 times 2 is 4. Then 3 times 2 is 6. So this will be 10, 20. So answer is 20. So is the answer 20? 2 plus 8, 10. 4 plus 6, also 10. 10 plus 10, 20. So this is correct. So this shows us that the formula n over 2, 2a plus n minus 1d, right, is correct. Now, how about the other formula? The other formula. Sn equal to n over 2a plus l. Okay. Now, if you look at this sequence here, 2, 4, 6, 8, 10 until 100. Until 100. And I want to know how many terms are there at number 100. Do you know how many terms are there?
No.
Can you find out how many terms are there?
Yes.
How to find out? How to find? We call this term what? T
N.
Tn, right? We call it Tn. We call this Tn. Tn equals to 100. If Tn is 100, a plus n minus 1 d is 100. Here, very small. Okay, never mind. So next, we are going to say that a is 2 plus n don't know, n minus 1. D is how much? 2 equals to 100. Okay. 2 bracket n minus 1 equals to 98. So divided by 2 is how much? So n minus 1 equals to 98 divided by 2 is 49.
49.
49. So what is the n?
50.
Yes, correct. Very good. So I know that there are now altogether 50 terms. Now I want to sum from 2 to 100. How? Okay. Now I don't want to use this first formula. I want to use the second formula. So I know that there are 50 terms. So I want to find S50. I want to find S50. S50, right? Can you tell me what to write down there? According to this formula, hmm?
4 to
N over 2. This formula say N over 2. So what should I put at the top?
50.
50. What should I put at the bottom?
2.
Correct, 2. Right. Then I have this. Sorry. What is the formula? A. How much I write down there? Write down here.
2.
2 plus L. L is the
1.
last. How much is it?
500.
1?
100.
100, right? So now it will be 25 times 102. 25 times 102. Can you use your calculator and find out how much is 25, 102? You tell me, then I write down.
2,500.
Sorry?
2,550.
2,550. Is this the number? I typed correctly or not?
Yes.
Yes, okay, very good. So now, fine, right? Okay, very good. So everything is correct. And we go on to question number 1A. Oh, sudah lari. Okay, question number 1. You read the question number 1 and see.
Calculate the sum of each of the following arithmetic progressions.
Okay, so question number 1A, right? Can you tell me what is A?
-9, -6.5, -4, up to the first 15 terms.
So A is -9, right? What is the D? D is -6.5. I
Yes.
typed wrongly, or -6.5 minus -9.
Minus.
Because it's always minus, then the first term is -9, so minus -9. How much is this? Is it 2.5?
Yes.
Yes, 2.5. Then they asked me to find the sum of the first 15 terms. Can you see the word first there? Can you
Yes.
remember why they use the word first there?
Yes.
Yes, we start from the first term. First means they must start from first term. Right. So here 2A n minus 1D. The D is not 3. The D is 2.5. The D is 2.5. This is 18. 14 times 2.5. Can you tell me what is 14.2.5 using your calculator?
Mm. 14, 55,
35, correct. 35. 35 minus 18. 35 minus 18. 17. 17.
17.
Okay. Times by 7.5. Correct. 14. Okay. Answer is 127.5. Now, how come this number is not a whole number? Can you tell me? Can you tell me why this number is not a whole number?
Mm.
Normally, we get this number, very nice number, no decimal place. Why now got decimal place?
Yeah, the sum need to divide 2.
Yes, because the common difference is 2.5. It's not a whole number. So the sum also probably it can be a whole number. It may not be a whole number, right? So sometimes it can be whole number if this is a whole number. If it's not a whole number, then the sum is not a whole number.
Mm.
We're going to look at number 1D. Number 1D, can you tell me what is the A here? 1.5, right?
Negative.
1.5, which is 1.5, let's say 1.5. Now, if I want to find out what is the D, I take this term behind 1 and 1/4 minus 1.5. So 1 and 1/4 is actually 1.25. Now, if you have a scientific calculator, then you just type there 1 and 1/4. Because just now I want to calculate mentally, so I use decimal faster, right? Not want to calculate that because the typing is very difficult. You have to type the fraction is very difficult. So I just type the decimal is easier for me. So 1.25 minus 1.5. So answer is negative 0.25.
Mm.
Negative 0.25, right? So that is our value of D. Then the last term is -2. And I don't know the term number for -2. Maybe it's the 10th term, maybe it's the 6th term, don't know, right? So I call it Tn. I call it Tn. So I try to find out what is the value of n. Then later on I can find the value of n, right? So I call it Tn. I call it Tn. Tn is a plus n minus 1d. Tn is 2, -2, a is 1.5, n don't know, d is negative 0.25. Now again, you look at how I do it. I didn't open up the bracket. I didn't multiply the negative 0.25 inside the n minus 1. Why? Because if I multiply the negative decimal place inside, it will be very complicated. Negative, then decimal some more, right? So I just keep it like that in the bracket form. Then the 1.5, I move over to the other side. It becomes negative 3.5. Now I can deal with the negative 0.25. Negative 0.25, and this is negative 3.5. I divide by negative 0.25, and I have 14. Now, although earlier on, our sum is a decimal number, now this n is always a whole number because it is the term number. We say first term, second term, third term, and so on. We cannot have 3.5 terms or one, 8.25 terms. We cannot have that. So because the term number is a whole number, so the n here is always a whole number. The n is always a whole number. The Tn and the Sn, they can be whole number or decimal. Depends on the question. Okay, so we found out that this Tn is n is 15. They are all together 15 terms. So if I want to find the Sn, which formula should I use? Should I use this 2a plus n minus 1d or a plus L? Now, because the last term is known, is negative 2, so it is easier to use the formula with the last term. So Sn equal to n over 2, a plus L. So if I want to find, because I know n is 15, so altogether in this sequence, there are 15 terms. So I have to find S15. So to find S15, I quote the formula 15 over 2, 1.5 plus, this time no n minus 1t. This time is L, right? A is 1.5. L is negative 2. Okay, very simple. Right? So 1.5 minus 2, 0.5. 0.5, you multiply with 0.75, answer is 3.75. So far, you have any question to ask regarding the Sn? Can follow?
Yeah.
Any question?
Yes.
No question. No question, then we move on. Yeah, I mean, you better do some question. So earlier on, I asked you to do 3 questions. Now we have, so you try question. Oh, here we have the multiple of 7 again. So you try number 1, number 2, number 3, number 4. Okay, you try number 1 until number 5. Number 1 until number 5. Okay, so 3 questions plus 5 questions, 8 questions. Okay, we move on. Now the next one is geometric sequence. Now this geometric sequence, I don't know, our first lesson, I show you 3 types of sequences, three sequences. One is called the arithmetic sequence, another is geometric sequence, and the last one is the square. 1 square, 2 square, 3 square, like that. So square sequence. You look at this sequence here. This sequence is called the geometric sequence. Now, how is it different from arithmetic sequence? You look at the number here, 3, 6, 12, 24. Do you know what is the next number here? 3, then go to 6. Next one is how much?
48.
48, correct. Now, how we move from one number to another in our arithmetic progression, we move from one number to another to the next consecutive term by adding. This one is by multiplying. Okay, always multiply, no divide, always multiply. Okay, so multiply by 2, multiply by 2. So the answer is multiply by 2. Now, if you look at the next sequence, instead of the number becoming bigger and bigger, the number become smaller and smaller. 2, 2/3, 2/9, 2/27, and so on. Now, this sequence, the value of each, the following term is smaller and smaller. Now, how to make the number smaller and smaller if you need to multiply with a number? What number should you multiply to get the next number here? What is the next number in the sequence? Can or not? Can you answer?
2/81.
2/81. Well, how to get the 2/81? You multiply with 1/3. So in this geometric sequence, to move from one number to another, you multiply with a number. Instead of a whole number, you are actually multiplying with a fraction, which is smaller than 1. Fraction also can be bigger than 1, but that number is smaller than 1. So as a result, the term becomes smaller and smaller, right? So now we have two types of geometric sequence. The first one, the value become bigger and bigger. The second one, the value become smaller and smaller. The first one, you multiply with a number bigger than 1. The second one, you multiply with a number smaller than 1. That's how we get this. Okay, now we try to analyze the sequence. So I call the first number as what we did for the arithmetic progression. The first number, I call it A. And I call it T1 also. So it's equals to 3. This one, the first one I'm referring to. Now, how to get T2? I take the first number, multiply by 2, then I get 6. That's how we get 6. How to get 12? 6, I multiply by 2, I will get 12. But instead of writing 6, I write down 3 times 2. 3 times 2 is actually the 6. Then I multiply with another 2, I get 24. I get 12, sorry. Now, how to get the next number? I take 3, multiply by 2, multiply by 2. Then multiply by one more 2. That's how I get 24. And so on, and so on. Now, let's say I want the 10th term. Actually, the 10th term is very easy one. Why? Because I need to take 3, multiply by 2, multiply by 2, multiply by 2, then I will get the 10th term. But the question now is, how many 2's should I multiply? Do you know how many 2's?
9.
9. Wow,
9.
good, very good, correct, it's 9. Right. You can understand, right? I better put down 9, oh, so that I put down 9 there, right? 9. Hey, yes, yes. It's 9. Very good boy, right? 9. Now, let's say, now I don't want to tell you the value of the term, I mean the term number. Let's say I want Tn, it will be 3 times 2 times 2 times 2. I don't know how many 2. Can you tell me how many 2? Huh?
No,
N number of 2s. Huh?
no, no.
How many 2s should I multiply?
And
N 2s. Oh, no, not N2. You see here, oh, if I want the 10th term, I cannot put 10.
n minus 1.
Sorry?
N minus 1.
Ah, very good, very clever. So this one should be n minus 1. N minus 1. And minus 1. Bagus. Okay. Another thing I want you to know is the number that we multiply, instead of calling it common difference, we call it the common ratio. Because of ratio, we use the letter small r. We call this number here, or this type of numbers here. We call this number here like multiply by 2, then the r is 2. If we multiply with 1/3, then we call the r 1/3. So if I want to know what is the value of r, instead of using the term behind, subtract the term in front. I use the term behind, I divide by the term in front. 6 divided by 2. How much is it? 2. So I say that the common ratio is 2. If I take 12 divided by 6, what's the answer? Also 2, right? So it's something like our arithmetic sequence, but instead of subtracting, we just divide, right, to get the common ratio. So you just take 24 divided by 12, also you get. But you must take 2 consecutive terms. You cannot take 1 term here, 1 term there, then you divide and you say that is the common ratio. You must take consecutive terms, right? Now, I want to ask you in your opinion what is the formula for En for geometric sequence? For geometric sequence.
Tn equals to a times n minus 1.
Okay, so actually we see from here 3 times 2 to the power of n minus 1. What is this 3? 3 is actually the first term.
A.
Then the 2 to the power of n minus 1. What is actually the 2?
Common difference.
Common ratio.
Common ratio.
The r. The 2 is actually the r, the common ratio. So instead of putting n, it will be n minus 1, right? It will be n minus 1. So now we have another formula. Tn, this Tn is for geometric sequence, is ar to the power of n minus 1. So with this, oh yeah, another one. We have another formula, right? We have the r. How to find the r? The r is, we have this
T2 divided T1.
This one will be n. This is Tn. This is Tn. And divided by Tn minus 1. Tn minus 1. Okay. So this is our formula for finding R. This is the formula for finding Tn. This is the formula for finding R. Okay. Right. Okay. If you look at the question in your lecture notes, find the first, write down the first 6 terms. They give you the A and the R. Then find the 15 terms. Then find the A and R. Example number 2, term in the geometric, right? I cannot see. Find the 8th term in the geometric progression, whose first 3 term is this. So you try this example 1 and example 2. Then we continue. Next week, you celebrate Chinese New Year or not, actually? Hello? Joshua, you celebrate Chinese New Year or not? Huh?
A bit.
A bit. Your father celebrate or your mother celebrate?
Mother.
Mother, your mother celebrate. Okay, so I also celebrate Chinese New Year. So Saturday, Sunday celebrating. So Monday, can you have the lesson on Tuesday or not?
Yes.
Okay, then we continue next week Tuesday, right? So you try these 2 and the other 8 questions. So we stop here. Only 7 minutes left, right? We stop here.